So this is what we're going to make. There's me. Hi. So there's a lot going on here. This will probably take a few videos. So basically, I call it Webcam Piano, and I'll explain why. I call it that. We can change keys. So I'll go through all this. Chromatic is quite cacophonous. The pentatonic sounds quite good. Diminished is a bit more tense, and I just threw in a Turkish makam, as we call it. Actually, for this one, it's a lot better with fewer. Oh, and I forgot to mention we can also choose different instruments and even different instruments in different parts. So, for example, the left side is piano, and let's make the right side this weird synthy thing, and then the middle I'll make a weird synth, another synth. Okay, let's get into it. Yeah, basically it starts with, let me just turn it off. I'll just summarize what we're going to go through. There's the video, there's me, and we do something called frame differencing, which is finding pixels that are changing. It's a bit like the optical flow, but different to the optical flow that you have built into Touchdesigner. Then we create this grid, which is a customizable, grid size. We pixelate we find the movements in the grid. Let's turn that off. So yeah, these are the pixels that are changing. Let me put the video on so you can see. And then from that, we will also go into 3D. Let's get rid of these. And all of this is done using pops. Let me put the music back on. All of this is, let me just say, done using pops. Not even the 3D, even the music logic I did using pops. I've just found it easier that way. And yes, that's what we're gonna go through. But before I jump into that, I want to just go into, yeah, basically where this came from. I made a series of work called Webcam Piano. Oh, there it is. Quite some time ago. The better known version was in 2010. It's basically very similar, although here I'm using a different technique, which I am going to talk about. If you'll notice, only the kind of fingertips or the edges are creating sounds. And this is back in 2010. In fact, I started in 2007. In those days, we didn't have things like Connect, or we didn't have affordable depth sensors, and we obviously didn't have things like Media Pipe. But I'm going to talk about all that stuff. So I was using a bit more advanced things, which I am not going to go into, but I'm going to mention. I was doing blob tracking here, and again we have the different scales. I'm not going to cover exactly what was going on here because that's going to be a bit too advanced, but I'm going to mention it. But a much earlier version, 2007, this is basically using the same technique that I'm going to go into in this series of videos. So yeah, this was 2007, this was all C++, but I also want to go back a couple more decades, because really, if we're talking about this lineage of work, it's very important to speak about David Rockaby's Very Nervous System, which is a series of work that he made in the 80s. David's a Canadian artist, and he's actually been, this is a series of works. There was a work called Body Language, and before that there was a series called Reflections. This is all in the 80s, and I really encourage you to go and watch these videos because they're remarkable. They just sound incredibly good. And he hand-wired the sensors. Like you can see these boxes here. He handmade these. They're effectively low-resolution cameras. I believe these are 16 by 16 pixels. These ones I think are 8 by 8. I remember reading that somewhere. And so yes, please do watch. It's remarkably expressive, and it's also good to know what people were doing, you know, back in the 80s and even earlier. So let's get into it. Okay, here we are in a blank Touchdesigner. I am using version 30770, which was released August 9, which is just a couple of weeks ago, and earlier versions of Touchdesigner will not work. There was something about the pops, I can't remember what it is, but it didn't work. And this is experimental, so if you're watching this video many months from now, maybe something will change in pops and you'll be wondering, you know, why don't I have that thing? This will work with 30770, and I'm sure future versions, even if the UI changes, there will be a way to do it. So first thing, I want to create this project tidy from the beginning. So I'm going to create a base comp. Like instead of just putting everything, building the whole network here, I want to put things in comp straight away. So I'm going to create a base comp, call this video input. I'm going to go inside and I'm going to drop in my webcam. Oh, sorry, it's called video device in. Okay, there we go. There I am. Hi. And then I'm going to flip it because it feels weird. That's my left hand, so let's flip the X. Then we don't necessarily have to do this, but I'm going to do it, just makes things easier. I'm going to do a fit, and I want to fit it to, so first of all, let's go back to the webcam, and it's at 640, 480. Let's make that 1920 by 1080 at 30. You don't need to do this, but I'm going to do that. It's better quality. Oh yeah, there's a massive lag. You don't notice this, but there's a massive delay, so I need to change that to, I think, Media Foundation. And do that again. I don't know why, but on my computer, yeah, that's better. Now there's no latency. I'm going to do a fit, and I'm going to fit it to 1920 by 1080. The reason is if I might want to change this. I might want to change this to 1920 by 1200, and I want to, for the fit, I want to do not fit best, I want to do fit outside. So if I change it to, for example, I want to make it 1200 by 1200, here I just have it nicer. It's just cropping. So I can change my resolution if I want 800 to 800, or if I want it to be 800 by 1600, you know, I have this. But let's keep that at 1920 by 1080 for now. That's what I'm going to work at. And then let's add a out. And I'm going to call this capital out. And I'm going to go to my video input, right click, customize component, and take my fit resolution and drag and drop there. Bind as new parameter. Now I can go up, and there's my video input, and I can change the resolution from here. I've got a nice little unit thing. So now that's done, we can move on to the next thing. So for the next thing, first I want to go into my video input. This is also good having this separate, because if later, I'm not going to do this in this series of videos, but you could, for example, replace this video input with media pipe and then extract the hands and then connect the hands to this so it just detects hands. And then the rest of the graph, will be unaffected. So that's why it's also good to modularize what's going on. So for now, I'm going to go in, I'm going to drop a movie file in. This is just a temporary thing because I want to show some things. And I want to open this one, count. Okay, and I'm going to connect that count to this. So now if I come back out, let's create a new base comp. So now we're going to start the frame differencing and go inside the base comp, create a in top. Actually, it would have been easier. Let me just, let me do this. Let me create a null and then create another null and then select that, right click here and collapse selected. That way the input and output is already wired. And let's call this one diff. So I want to talk about frame differencing. I've just jumped inside it. There's our input and there's our output. At the moment nothing's happening. In fact, we can delete that null in there. So I'm inside diff. So optical flow, you might be familiar with. It basically, there's two optical flows. There's one which is here, and there's one which lives here under tools. Is under, yeah, optical flow. And they both do similar things, which is they take a video feed and then they find the pixels that are moving, and they also find the vector, the direction in which that pixel is moving. This is a bit advanced and a bit too heavy for what we need. For this project, we don't need to know the direction of movement. You could adapt it to work like that, but so I'm going to do this from scratch. What we want to do is you want to basically take a very simple subtraction between the current frame and a previous frame. So to do that, let's add a cache. And what cache does is, there's a cache size which is 32. It's buffering the last 32 pixels. And we can do cache select. And we can tell cache select, there's my cache top. And I'm going to pause it. At the moment, cache select, the cache index is 0. And if I do let's do -1, it's one frame previous. So as I step through, you can see that's 36, that's 35. If I say, give me 5 frames previous, you can see it's 5. That's why I picked this video, because it's very easy to see. So as I'm stepping through, you can see that there's 5 frames difference. Actually, we don't even need to use the cache select. You can even do it straight on the cache itself, where here it says output index. So I can even type -1 there. And now as I step through, you can see that that one's 61, that one's 60. So normally, if my webcam was running at 60 frames per second, because my patch here is running at 60, then just 1 frame previous is sufficient. But actually, I'm jumping ahead of myself. So now what we want to do is, we have this input and we have this input, which is 1 frame previously. We just need to subtract them from each other. A simple subtract. And let's output that. So now the order doesn't matter. As I step through, all that what we're seeing here is the difference between that frame, the mathematical difference between these 2 frames. And if I go back to my cache, if I say output index, at the moment there's 1 frame difference. If I say -5, so 5 frame difference, you can see that there is more pixels which are different. Right? That should hopefully make sense. So let's play that. Let's go back to the cache and play with this. So that's 1 frame difference, 10 frame difference. You can see that the difference is bigger. Okay, now that we've done that, we can go back up, go back here, and let's reconnect our video. And go back into diff. And you can see now when I move my hand, there's all those pixels. The non-zero pixels are where the movement is happening. And in my cache, if I say look at 1 pixel difference. Now if we say 1 pixel difference, there's going to be a lot of flickering because my camera at best is capturing at 30 frames per second, whereas my patch is running at 60 frames per second. So I don't want to look at the 1 previous frame because that's going to be no difference, a bit of difference, no difference, a bit of difference, because my camera's capturing at 30. It might even be capturing at 15, depending on lighting conditions. It might even be capturing at 12. So I'm going to say, look at 5 frames before. So that way the movement is also more accentuated. So the first thing is I want to do, this is color. I don't want it to be color. We don't need color. So here I'm going to add a mono. I want to convert this signal, oops. I want to convert this signal to monochrome. Okay, so that's better. So I have the pixels that are changing are non-black. Yeah, non-black, they're non-zero. The other thing I want to do, this is not that important for the differencing, but it is important for further downstream. I want to convert this to floating point. So at the moment, if I middle click, this is 8-bit fixed RGBA, which means all the pixel values are going to be between 0 and 255, and they're going to be integers. I want this to be floating point, so they're going to be between 0 and 1, and they're going to have, so they're not just going to be integers, they're going to have all the in-betweens. They're also going to be potentially greater than 1 and also potentially less than 0, which I'm going to need to address as well. So pixel format, let's change that to 16-bit RGBA. I could do 32 bits, that just increases the precision, but I don't need that level of precision, and it's just going to use double the memory. So 16-bit float, there we go. So now there's going to be negative values here. If I go to normalized split, you can, so just to repeat what I did, I clicked this to go into this edit mode, right click and selected normalized split. So we can see the red, green, blue channels independently and normalized with the range. And they're all showing the same image because we have a grayscale image coming in, but you can see that there are negative numbers, and I don't want that. So let's add a function afterwards. And here, let's do function RGBA absolute value. So now all my numbers are between 0 and 1. And if I go and do normalized split, this is a lot better. So no movement is 0. Some movement is greater than 0. So one problem we're going to have is noise. You can see there's still a lot of flickering, and there's probably most of this is non-zero. So what I want to do, the first thing I want to do actually, immediately after the mono, I want to add a blur. And let's actually, whoops, let's take this and put that there to compare. So if I bypass the blur, you can see there's a lot more noise. If I put the blur on, And let's increase the blur actually. Oh wow, it's going crazy. Oh, sorry, I'm stupid. Okay, I'll tell you why it's occasionally going crazy. Because I'm in a normalized split. If I stop moving, it's when it starts going crazy. Because you can see the range is dropping. So it's renormalized. This image feed is renormalized. So I need to go back into a normal color. And let's actually also, in the subtract, let's not do the alpha. Okay, so I'm not subtracting the alpha channels. That way the alpha channel is always going to be 1. So this is always background black. If I do subtract the alpha here as well, you can see that where there's no movement, it's also see-through. And that's fine, but it just makes visualization more difficult. So on the subtract, I'm going to not subtract the alphas. I'm just going to operate the channel mask RGB. I'm subtracting the RGB of this from this. The order doesn't matter because I take the absolute value. And now let me disable the blur. So you can see there's a bit more flickering, it's a bit more noisy. Let's put the blur back on. And it's a lot more stable. So how much blur, that depends on the camera noise. And if it's super noisy, you might have to even up the pre-shrink a bit. But we'll make all these parameters later. So we've got that there. We've got the function. And that's about it. Let's do an out. Let's call that out rather. Oh no, that's not it. So the next thing we want to do, we blurred a bit, that removed a bit of the noise, but also I want to set a threshold. So I'm going to add a level. And I just want to play with the black level. So just what this is going to do is this is going to cut the bottom of the curve of this. So things that are close to black are going to be black. So just to accentuate it, like, look at the difference between this, which has the black level, and that. Like, I'm moving very subtly, and all of this bit is non-zero. You know, I don't want that. I want something a bit more like this, where I have to make intentional movements. But again, that's up to you. We'll make that a parameter. At 0, it's going to be very super sensitive, and the higher you make this, the less sensitive. So there, you can see I'm moving, but nothing's triggering. But if I move really big, oh yeah, this is above 1. It can't be, if it's above 1, it's never going to work. So about there, like, I have to move really big, and then some bits are picking up. Okay, so we've done that. Now let's close that. Let's, this was a comp. Let's right click, customize component. What do we want to customize? The blur. We want to customize the blur. Let's add the pre-shrink and the filter size. Let's call this custom. Anything else? No, we don't need to customize the Catmull ROM. Let's definitely add a parameter output index. Oops, that's not what I wanted to do. Let's put the output index. So how many frames behind? Also, the cache size is locked to 32. You know, so that this means that it's caching 32 frames, but we're only using the -5th frame. So we don't need 32 frames to be cached. So I'm going to put this there, make it a reference. And so that's -5. I want to say minus that +1. So it's caching 6 frames now. And I'm using the -5, which is the 6th because it starts at 0. If I made this 0, that means use the current frame. So it's cache size 1. If I say use 1 previous frame, it means I need a cache size of 2, the current frame and the previous frame. Also, when I say use the 1 previous frame, you can see how it's flickering like crazy. That's because, again, my camera is capturing at 30 FPS, whereas I'm running this patch at 60 FPS. So there's every other Touchdesigner frame, I get a new camera frame. I want to make that about -5 to be really safe, and in case my camera frame rate drops to like 15 or lower. Next, we've got that, and also I'm going to right click and do parameters so we can see what it looks like. We got that. Function, there's nothing there. Level, we want the black level. Let's put that there. I'll just call these blur pre-shrink, blur size, cache index, and this one I'll call threshold. That's out. Is this not? Oh, there it is. Okay. And let's see. Yeah, we never want this to be above 1, so I'm going to customize this again. Make the black level range 0 to 1. Output index from, we're never going to want to go back that far. Let's say -20, and the rest is fine. Probably these are going to be like good settings. Okay. Let's go to the next one. Let's add a null here. And select it, right click. So next what we want to do is we want to pixelate this. So I will select that and do collapse selected and call it pixelate. But what are we going to pixelate it to? So actually first I want to do something different. I'll create an empty base here and call this one grid. So we want to pixelate this, but I want to create a grid for visualization purposes. That's going to make my life a lot easier. And let's go inside here. Okay, so I want to create a grid. You know, the first thing to do, this could be a SOP. Let's just make it a pop. It makes no difference, because this is just purely for visual at this point. So we create a grid, and this is going to be the grid that I use to decide how to chop things up. So the first thing I want to do is its size. I want its size to match my video. So I'm going to customize this, and I could do this actually. I could just do customize and then take the size and drag and drop it there, bind. But this is a size 3. The Z size is completely irrelevant. So I'm going to make this a size 2. I also don't want it to be XYZW. I just want it to be an int. And the reason is, it's just going to get quite messy. Oh, wait, actually I should have looked at this. So here, these are size 1, size 2. If I make it XYZW, then it's size X, size Y, and it just got mixed up. Like some are 1, 2, some are XY. I'm just going to make them all int size 2. There we go. Size 1, size 2. And so now we get an error because these are referring to size X and Y. So I need to make that size 1, need to make that size 2. And this one, we don't want it to be linked to anything. That's just going to be 1. So again, this is my project 1 grid, and so I can make this 1920 by 1080. But of course, I don't even want to do that. Let's just go up immediately and take this resolution. Let's copy that, and let's bind it to that. So that way my grid size is linked, hardwired to my video size. And if I make my video, if I decide to make it like this, then my grid will also take that shape. The other thing I want to choose is the number of cells. So I'm going to immediately right click on this and create a new thing called cells. And that's also going to be an int of size 2. And let's add that. Oh, sorry, cells. That should be a size 2. And I never want it to be as low as 0. Let's say between 1 and 100. So this is the number of cells. And let's make the default, the min should be 1. And the default, let's make it 10 by, let's make it 12 by 8. So this is on the grid. I'm again editing the grids. We've got size. Oh yeah, that's not right. The default, let's make the default 1920 by 1080. The min is 0 to, I don't know, let's make it up to 248 for both width and height. So this is, I'm editing the size, that one. And cells, 12 by 8. Okay, let's go in. So this is my grid. The size is linked to that. Let's leave that up there. Now we want to next change the columns and rows. First of all, let's select that, go there, press W so we can see it. So I can, now if I drag and drop the number of cells, 1, that to columns, let's bind that, and let's bind that one to rows. This is actually not correct. If I make the cells 3 by 3, you can see, oh, why is it showing like that? Okay, there's something weird with 3. Let's make it 4 by 4. So I've made the cells 4 by 4. So the number of columns is 4, the rows is 4. But here we can only see 3 by 3. The reason is these are the points. So there's 4, 1, 2, 3, 4 points. So if I make it, say, 5 by 4, oh, I see that weird line there is, let's make it 6 by 4. Okay. So 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4 points. That's correct, but I want the cells to be 6 by 4. So I need to add one. And I had done a bind, so I can't come and do this. That's going to give an error because bind is a kind of hard wiring where it's two-way. So here, if I change that, you can see that that's also changing. Bind is a two-way linking. I can change that, or I can change this. So it's very useful if you want two parameters to have the exact same value. But in our case, we don't. So I'm just going to reset that and reset this. And now let's take that and plonk it there as a reference and put that one there as a reference as well. And now I can say +1, +1. And so now if I say give me 6 by 4, let's say give me 5 by 3, I don't know if that's a bug, like when a line is on top of the axis, I'd expect to see the line. Yeah, that's weird. So let's say I want 5 by 3. So now I do have 1, 2, 3, 4, 5, 1, 2, 3. Okay, great. That's my grid. So let's render it. Right click. That goes into a geometry. We want a wireframe material. Okay. Oh yeah, we don't want the edges. So oh yeah, okay. So in the wireframe material, change this from GPU tessellated wireframe to topology of wireframe. There might be a better way to do this, but that's what I discovered works. So let's add a camera. It's here. And let's add a render top. Okay, so now the tricky thing is to be get the camera correct. So the size of this grid, if you recall, is 1920 by 1080. That's massive. We need to position the camera in such a way that this aligns perfectly to my view. Now, one very easy way of doing that is just make it orthographic. And then now let's have a look at our world. Let's split this left, right. Let's make this a geometry viewer. Let's view, okay, they're all there. Let's press H. Okay, so that's my grid. And where's my camera? It's there. So let's put that really far away. Let's see. So again, this width is 1920, so the camera is still super close. So actually, I'm moving it away, but I've made it orthographic. When it's orthographic, the distance doesn't actually make a difference. What makes a difference for the orthographic is this width. So if I make that 1920, then you can see that it's perfectly aligned. So what we could do is I can again take that size, or in fact I'll just take it from here, the grid. I'll take the X, copy, and paste that on the camera orthographic width. Paste that as a bind. Again, the camera's distance, see that blue dot is the camera, it's at 100, it's 500. With an orthographic camera, it makes no difference, and that orthographic camera has no perspective. And if I go and I make my video, 640 by 1080, then oh, actually, that made me realize, I also need to take that, copy, and I need to bind it to my render, oh, here, the render resolution, bind. So now my render resolution is also 640 by 1080, and the grid is perfectly mapped onto it. This is using an orthographic camera. However, I don't want to do this because later when I introduce the 3D, I don't want it to be orthographic. Just if I come back here and orthographic. In case you're not familiar, orthographic projection is like this. There's no perspective. Orthographic versus perspective. Let's see what's going to come up. Yeah, this is it basically. That's orthographic, that's perspective. I want perspective. So what I'm going to have to do is switch my camera back to perspective, and then I need to figure out a way of mapping this perfectly. And it just so happens that this is going to involve some trigonometry. You need to remember your tangents and your cosines. But I'm just going to say that just to keep things simple, I'm going to make the field of view of the camera 90, which is very wide. When I make the field of view 90, then I need to put the camera at a distance half of the width. So I'll copy that, I'll paste that there as a reference, and then I will divide that by 2. And the reason that is because half of 90 degrees is 45, and the tangent of 45 is 1, because basically, let's just say, how can I visualize? I'll go into this in another course. Basically, just for now, you can remember that if I make the field of view of the camera 90, then it needs to be at half the width away for it to fit the width perfectly. So if I make this back to 1920, then that width is 1920. My camera is at 960. There it is. One thing to be really careful of, let's say that I make this 20, let's say I make it 2400. It's disappeared. My camera is there. My camera is at 1200, which is correct, but I can see nothing. And the reason is something that maybe you've never have to encounter is the clipping plane, the far clipping plane. This is the distance beyond which the camera doesn't render anything. It's an optimization. So what I want to do is I'm just going to copy this, the camera distance, and I'm going to go and put that there as a reference, and I'm going to add one just for good measure. So the camera's clipping plane is going to be just 1 unit behind this. And you know that blue thing is my camera. If again I make it 640, the camera has gone right in there to frame it perfectly. Let's put that back to 1920. So now we have our grid, and the grid is fully adaptive and framed perfectly, and everything's good to go. Let's just add our out to it, and let's call that out, capital. Let's look at the parameters on this. We have the size and the number of cells. So if I make that 10, let's visualize that. 10 by 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5. Perfect. The one last thing I want to do, I'll do it while I'm here, is I want to add a reset button. So that's going to be a momentary, it's basically a button. Let's visualize it. Actually, no, not a momentary, sorry. Let's change that to a pulse. I'm not sure what the difference is actually. I haven't used it enough times. Let's make that a pulse. And here, if we change the number of cells, it's fine. We don't need to trigger anything. But there is going to be places where we do need to trigger something. We're going to create some feedback buffers, and we're going to need to reinitialize those feedback buffers when this changes. So what I want to do is here, I want to create that parameter execute. Let's turn that off. So this parameter execute, let's split this top bottom and make this that and put that there. Basically, this is just to edit the code. This parameter execute, what is going to execute some script. Oh yeah, there's going to be a lot of coding in this series of videos. I forgot to mention. It's going to be a lot of a little bit of Python and a little bit of GLSL. Should have mentioned that up front. Anyway, so we want to watch the parent, which is basically the parameters of the parent, which is this. We want to watch that. And the parameters we want to watch for is the cells. So let's write cells star. And we want to on value change, not on pulse. And here, this is the code for it. You can also just do view, edit it there, or you can just click the edit button, but I'm just going to do it here. So we don't need on mode change, on enable change, on expression change, on pulse. We don't need any of that stuff. We don't need that. We just need this one, and just let's do print car. So now let's go to the text port. If I change this, you can see as I change it, or if I change that one, this code is being triggered. So if I say par.name, par, okay, great. So now all we want to do is we want to trigger this reset button. And later, this reset button is going to do nothing, but I'm going to bind stuff to it in other places. So all we need to do is and I'll just keep that for now. Basically, how do I call that? So that is in my parent of this node. So we're in this node right now. So the parent of this is the whole patch, which is the grid. So parent, we want to get the parameters of the parent. par. That's just the object for it. And then we want to fetch the reset parameter. So it's called reset with a capital R. It's not what you see here. This is just the human readable version. The version that matters is this also. So when you're customizing here, the parameter, that's the machine readable name, and the label is the human readable. So for reset, if I call that reset the thing, that's what you see there, but this is the internal name, reset. And it always has to be, it always starts with a capital for custom. Even if I make it lowercase, it's going to reset. Even if I type reset the thing, that's going to be renamed to that. Anyway, so let's put that back. So reset, and then it has a method called pulse. How do I know all this? It's in the documentation. You'll start learning all this stuff. But basically, so now when I change that, this should be pulsing. How can we check it? We will see later that it is going to be working. Actually, let's not be lazy. Let's try, for example, I want to see if that's actually working. Let's get a constant chop and make that value 1. Put that into a speed. Okay, so that's increasing, and there's a reset there, and I can press that pulse, and that resets it, right? Let's make this bigger, so if I reset it, it goes to 0. So now let's take this reset and let's bind it to that. So now, hopefully, if I change this, that should reset. Boom, there you go. It works. So if I change either of the cells, as soon as I press enter, that's going to go to 0, because changing that triggered this code. That code triggered this reset. That reset is linked to this, and it's resetting that. And later we will link this to all of our feedback buffers, etc. Okay, we can get rid of that. And I think our grid is done. Good. Now we can go into pixelating this. So the first thing I want to do, I want to customize this component, and I want to drag both of these here and bind them. Whoops. Wait, so this one I want to customize. What just happened? I think I chose the wrong thing and messed it up. Yeah. So here I want to customize that, and from the grid, oh yeah, I did the binding the wrong way around. Let's get rid of that. I want to drag and drop that there. I want that to be the master, so bind project 1 video input resolution as reference to new par. No, I want to bind to new par. Replace bind on source. No. Let's do bind new par as reference, and also let's get that one. No, I did it the wrong way around. You know what? Okay. Here's what I'm going to do. Parameters. So this is my pixelate. This is my grid. That's the pixelate. Oh yeah, that's correct. And then this one, let's bind that there and resets that. Yeah, sorry for all the confusion. See, I get it wrong as well. Yeah, so this is the pixelate parameters, and it's reading from the grid. So why don't we make this the master? I'm going to reset that and copy that and bind it onto here. Okay, so this is my master now. I'm going to make that red. So I control everything from here. So if I make that 640, okay, that's that. And also here, that's 640. And if I make that, for example, 5 by 8, that's 5 by 8. The advantage of binding is you can do it from anywhere. I can actually change it from here as well. So that's 900, etc. But still, this is my master. So, good. My pixelate has the size and the number of cells. And now let's go in. What we want to do is very simple. We just want to pixelate this. And the way to do that, let's get rid of that. We want to resize it down. So let's just use resolution and open up these parameters, common, use custom resolution, and we want to resize it down, to this. And let's bind. So for example, 12 by 8. Now the issue is we don't want this to happen. The graphics driver, usually this is what people want. They don't want blocky pixelated things, so when you resize, there's interpolation going on. We don't want that. So we have to override that by saying the input smoothness, instead of interpolating, we want nearest pixel. So now internally, this is not being interpolated, but still the viewer is interpolating. So we also need to make that the nearest pixel. So now we have this, which is 1920 by 1080, 16-bit float, being resized down to 12 by 8, 16-bit, and it's not being interpolated. So that's good. This is what I'm going to use for my maths and all my processing. But for viewing purposes, I want to resize this back up, because if I were to, for example, composite this with that, and let's say I screen them, it's, well, not soft light, let's add them. It's still being interpolated here, because what it's doing is it's resizing this internally up to back to this resolution, and then it's compositing them. But while it's resizing it up, it's again interpolating. And I could probably change that. Let's see if I said nearest pixels. Yeah, so I can change that on the composite node, but then every time I use this, I'm going to need to go and change this to the nearest pixel. So I'm just going to do that here, and resolution, and let's take the original size, copy parameter, custom, let's bind that. Okay, so now this is resized up to 1920, and now I just do it once, nearest pixel. Okay, so now that's that. So from now on, I don't need to worry about doing nearest pixel. If I composite this with that, for example, and let's make that add, this, it's already going to be pixelated. It's not going to be smooth because I've taken care of that. This looks pixelated, but it's 1920 by 1080. This is purely for visual purposes, this one. So let's call that res, high res. And then this one is the low res. This one is the one I'm going to use for my actual maths. And then let's call that this one out, which is my main out. And then I'm going to create another out. And this one I'm going to call out high, which is for my visualization. You can see here again, this looks blurry. That's because the viewer smoothness is interpolated. This is purely for this viewer, so it's not an issue, but just so that I don't get confused, I'm going to do that. So now we have the pixelate, and let's put that on. Great, we're looking good. So the next thing I want to do is I want to start building my visualizer, and there is a, where was it, I wonder? Multi-mix. So I open the panel. On the tools there's a multi-mixer, and here let's take that master resolution and put it there, paste bind. This is like a Photoshop layer system. And so for layer 1, let's take this. Can I do that? No, I can't. Okay. Video input / out. Okay, there, and that's my opacity. My layer 2, let's take this one. So this is also why I like doing this out. This is kind of like a standard thing in Houdini. But actually, a lot of this, I should give a shout out to Immersive HQ. I learned a lot from Immersive HQ's kind of master classes on how to organize projects. So anyway, yeah, grid out, layer 2 is grid out, and you can see, in fact, let's do this. Let's add a out there, and this is my master out for my whole patch. Let's visualize that there. I don't like seeing it in the background, it's messy, so right click, display, get rid of the background top, and instead let's convert this to a top viewer. And yeah, there we go. Okay, so this is a top viewer visualizing my project 1 output, which is this, and my layer 2 opacity, there we go, that's the grid. Layer 1 is my video. Then layer 3, let's take the diff out. And layer 4, let's take pixelate, but not the out, because the out is the low res version. Let's okay, we can take the low res version. Probably because this is the, not the diff, sorry, pixelate. So we actually don't even need the high res version. Okay, all good. And then that was layer 3 is the diff out, layer 4 is the pixelate out. And yeah, I think this is a good, oh no, one last thing I will do. I'm going to stop, take a break. For now, I will just create, I like creating master GUIs. I don't know if this is the best way to do it, but the way I do it is, let's create a container comp. And I'm going to start collecting all of my parameters that I want to use into this single place. So, for example, size, let's put that there, and bind that to that. Let's put that there, bind, let's put that reset, bind. So now this is going to become my new master, and in fact let's also, oops, there, parameters. So grid, let's not call it grid, let's call that custom. So here I'm going to start collecting all of my parameters, and I'll be grouping them, etc. So what else do we want? Let's call this init, and let's create a header. And I'll update this as we go along as well. So that's my init header. Let's put that up there. Then next we have diff, so let's create a diff header. And I like giving them sections, so it's quite different. So we want that. Bind, we want the blur size. Thresholds. Next we want the pixelate. Oh, there's nothing on the pixelate. Then it's the layers. So let's create layers header. And then here the, oh wait, layer 1 opacity. and let's call that video. Layer layers, let's make it a section. Video, layer 2. That one is the grid. Let's put the layer 3 opacity. That one is the diff. I call it the diff because it's a frame difference. And then layer 4 is the pixelate. It's the pixelated diff, actually. And actually for each layer we also have a blend mode. Screen will be a little bit less harsh than add, so let's make them all screen. Okay, so here is our master GUI. The final thing to do is to bring this to that state where it's all in one window, and again this bit kind of confuses me a lot. I think the way I would do it is go inside and create a parameters comp. I want to make the layout, oh yeah, here, so horizontal mode, let's make that fill and make the vertical mode fill, and then go up, and here we want to make the container layout, the width, yeah, maybe like 400 is good, but the height, I want to get this height, 1080. So let's copy that parameter and paste that there. Okay, so now I've made this container, which is 400 wide. That's how wide the thing's going to be. And the height is 1080. And inside I have these parameters. This basically gets all the parameters, and this one is fill and fill, so I don't have to worry about the dimensions of that. Then I want to get another container. This one, where is it? The background top, I want to get out, which is basically this. And in fact, let's just make, just so that we see, let's put the diff on. Okay, yeah. So this is the background top, is the out of this, but the dimensions we need to get from here. I wish there was an easier way to do this. It drives me crazy every time. So let's put that, bind that there. So this is the grid, which is our master. Bind that there. Okay, so now we have two containers. That's the video. That's the output of our comp at the right resolution. This is all of our parameters. Actually, this is way too much. I don't want all of this, so go back to parameters. We don't want the built-in ones. We only want the custom ones. Yeah, otherwise this is everything. We just want the custom parameters. Okay. So this is the parameters that we created. That's that. So now let's create another container. It's got to be an easier way of doing this. And we link that and that. And now we take that width. Okay, bear with me now. So this is these two. I want them to be side by side, and I want it to have the width is going to be the width of this plus the width of this. So, and the height is going to be the height of this. So I can just take that second one, which is size 2, and put that there, paste bind. Okay, so the height is good. Now the width is going to be this number here. Let's copy that. Back to that width, open it up, expressions, put that there. Oh, no, sorry, paste reference. Okay, we get the width of that. That's 400. But we also need this, the width from there. And what we can do is, let's open that up, take that, plus 1. So this is 400, that bit, So op container 1, which is that, par.w, which is that 400, plus op grid.par.size1, which is the 1920. And then the height is that. Okay, so now the width of this is the width of that plus that. And then the next thing I need to do is, I think, was it in children, align left to right. There we go. Okay. So that was children, align left to right. Please someone tell me there's a much easier way to do this, because this kills me. Now that I've got that, let's create a window. And that window is gonna be looking at container 3. And I want it to open, close. Let's set that as the perform window. And opening size, I could just leave it like that, or I'm just going to do opening size fill. So now when I press F1, which is perform mode, it opens that, and here we go. So this is where I'm going to stop for now. This is working pretty good. In the next video, I'm going to show how to use this information and convert that to Midi, and I'll talk about what Midi is. And no 3D, we'll be using POPs, we'll be using some GLSL, and we'll be using some scripts to parse all this information, convert it to Midi, send it to a music application. That'll be the next video. And then probably there'll be one more video after that, which is how to convert all of this to the 3D cubes.